Right. Today we're going to take a look at simplifying rational expressions. A rational expression will have, in the numerator and denominator, it will have a polynomial, okay? So the first thing we're going to look at is we're going to take a rational expression and we're going to find what we call excluded values. An excluded value is the number that will make your denominator a zero. So our first set of instructions, we're going to state the excluded values. For each rational expression. So for example 1, if we have 5x over x squared minus 81. Now to find the excluded values, I'm looking for the numbers that will make my denominator a 0. So I'm just going to take a look at my denominator. I'm going to take my denominator and I'm going to set it up to be equal to 0. And if you recall, this is called the difference of two squares, so I'm going to write it in its factored form. The first term in each binomial will be a x. 9 times 9 gives you 81. This says minus, so that means I need to have a plus. I need to have a minus. Now I'll set this up using the zero product property. Take each factor, set it up to be equal to 0. Solve for x. So my excluded values for this problem are 9 and a negative 9, okay? So in other words, x cannot equal 9 or negative 9, okay? Why? Because if I take a positive 9 and put it here, 9 squared will give me 81. 81 minus 81 will be 0. And remember, a denominator of 0 is undefined. If I take the negative 9, replace it for x. A negative 9 squared is also 81, and 81 minus 81 gives us 0. So for excluded values, we're looking for numbers that will make our denominator a 0. Example 2. If I had 3x squared minus 2 divided by x squared plus 6x plus 8. Again, I'm going to take a look at my denominator. I'm going to take my denominator, set it up to be equal to 0. I have a trinomial that needs to be factored. And if you go back and recall how to factor, that is why I told you that you had to know how to factor. Are there two numbers I can multiply and get 8? Combine the two numbers and get 6. And those two numbers are a positive 2 and a positive 4. Take this product, set each factor up to be equal to 0, separated by the word or, because this is what we call a disjunction. So I get x is equal to negative 2, x is equal to negative 4. So that means my excluded values are negative 2, negative 4. So x cannot equal negative 2 or negative 4, because those two numbers would make my denominator a 0. Example 3, if I had y is equal to 8 over 2x plus 1, again, take that denominator, set it up to be equal to 0. This cannot be factored, but I can solve for x, transform the 1, divide by 2, So my excluded value for this problem is a negative 1/2. That means that x can be any number except a negative 1/2. Now we're going to simplify some rational expressions. Example 4. If I had 16x squared y raised to the 4th divided by 8x to the 3rd y. This is on this particular problem, you need to recall your rules for dividing like bases. Remember, when you divide like bases, you subtract exponents. So let's look at these numerical coefficients first. 16 divided by 8 gives us 2. I have x to the 2nd divided by x to the 3rd. The rule tells me to subtract the exponents, so I get x raised to the negative 1. 4 minus 1 gives me 3, so I get y to the 3rd. I have a negative exponent. I need to make it positive. In order to do that, I need to bring that down to my denominator, so my answer is 2y cubed. Bring the x down to your denominator. As you do that, that makes the exponent positive. Example 5. If I had 32, x to the 5th, y to the 2nd, and I want to divide that by 12, x, y to the 7th power. With 32 and 12 have a GCF of 4, so I'll take 32 divided by 4, I get 8. I'll take 12 divided by 4, I'll get 3. Now looking at my base of x, again, when you divide like bases, subtract the exponents. 5 minus 1 gives you 4, so I'll have x to the 4th. 2 minus 7 gives me a negative 5, so I have y raised to the negative 5. So my final answer is I need to make this exponent positive, so I'll get 8x to the 4th. Bring that y to the 5th down. As I bring it down, the exponent becomes positive. In the next part of the lesson, we're going to simplify each expression. And we're going to state the excluded values of the variables. Example 6. If I had n plus 3 divided by n squared plus 10n plus 21. Well, it asked me to simplify. So in order for me to simplify, I need to factor this denominator. So I'll have n plus 3 divided by, again, can you think of two numbers you can multiply and get 21, combine, get a positive 10. Those two numbers are a positive 3 and a positive 7. So I'll have the binomial n plus 3 times the binomial n plus 7. As I simplify, the n plus 3's will cancel out, leaving me with a 1 in my numerator. In my denominator, I'll have n plus 7. So this is the simplified answer for this problem. But it also asks me to find the excluded values. And let me go back and fix this right quick. State the excluded values. I apologize for that, right? So in order for me to find my excluded values, I will take this factor denominator, take each factor, set it up to be equal to 0, solve for x. So the simplified answer for the problem is 1 divided by n plus 7. The excluded values are a negative 3 and a negative 7. Example 7. If I had y squared plus 9y minus 10 and divide that by 2y plus 20. Again, I've been asked to simplify. So in my numerator, I have a trinomial. There are two numbers I can multiply and get a negative 10, combine and get a positive 9. To get a negative 10, one number has to be negative, one has to be positive. Since the 9 is positive, the greatest factor needs to be positive. So I will have a y plus 10 times a y minus 1. In my denominator, 2y and 20 have a GCF of 2, so I'll factor out a 2. And inside parentheses, I'll have y plus 10. As I simplify, the binomials y plus 10 will cancel. So the simplified answer for the problem is y minus 1 divided by 2. To find the excluded value, I'll take the y plus 10 because I can't say 2 equals 0, but I can say y plus 10 equals 0. So y is equal to a negative 10. So the excluded value for y would be a negative 10. Let's go back and recall something from a previous lesson. If you recall, x minus 5 and 5 minus x are opposites. If you take them and divide them, you will get a negative 1. So that's something that you need to remember. If I divide opposites, I get a negative 1. So let's continue to simplify. If I had 36 minus m squared divided by 5m minus 30. As I factor, if you recall, this is called the difference of two squares. So that means I'll have two binomials. The first term in each will be the same. So 6 times 6 gives you 36. M times m gives you m squared. That says minus, so that means I need a minus, I need a plus. In my denominator, 5m and 30 have a GCF of 5, so I'll factor out a 5, and I'll get 5 times the expression m minus 6. Well, 6 minus m and m minus 6 are opposites, so when I cancel this, I get a negative 1. So my answer is, I'm going to make the entire fraction negative. And for my excluded value, again, I can't say 5 equals 0. That would not be true, but I could do m minus 6 equals 0. So my excluded value for that problem would be a 6. Example 9. If I had x squared minus 2x minus 35 divided by x squared minus 9x plus 14. The first thing I need to do is factor. Can you think of two numbers you can multiply, get a negative 35, combine, get a negative 2. The greatest number needs to be negative. So if I take a negative 7 and a positive 5, when I multiply the negative 7 and positive 5, I get a negative 35. When I combine a negative 7 and a positive 5, I get a negative 2. Just trying to refresh your memory on factoring. I have a positive 14 here. I need two numbers I can multiply, get a positive 14, but combine, get a negative 9. So that means both numbers need to be negative. So I'm looking at a negative 7 and a negative 2. As I cancel, as I simplify, the simplified answer for the problem is x plus 5 divided by x minus 2. Then for my excluded values, I'll take that factor denominator, set each factor up to be equal to 0, solve for x. So the excluded values for the problem would be 7 and 2. This is a little lengthy lesson. Also in this lesson, we have to know how to find what we call zeros. Find the zeros of each function. The zeros will be the numbers that will make f of x equal 0, okay? Remember, that's functional notation, f of x. So as I look at problem number 10, if I have f of x is equal to x squared plus 2x minus 15, and that is divided by x plus 1. Now, My zeros will be numbers that will make f of x equals 0. So that means that what's going to make my numerator a 0? 0 divided by a number gives you 0. So the first thing we're going to do is we're going to replace the f of x with 0. We're going to factor that numerator. I need to see if I have two numbers I can multiply, get a negative 15, combine, get a positive 2, and those numbers would be a positive 5 and a negative 3. I can't do any cancellation on that problem, but I need to find my zeros. So I'm going to take my numerator, whatever is left in my numerator, and I'm going to set each one of those factors up to be equal to 0. Again, separated by that word or. So the zeros for this problem would be a negative 5 and a positive 3. So if I let x be a negative 5, my numerator would become 0. If I let x be 3, my numerator would become a 0. And the last example for this particular section, example 11, I want to make sure that you've got this. If I got f of x is equal to x squared plus 4x plus 8, and that should be a 6x plus 8, and we're dividing it by x squared plus x minus 2. Again, to find my zeros, I'm going to replace f of x with 0. I'm going to go on and factor this. Two numbers I can multiply, get 8, combine, and get 6. I would have an x plus 2 times an x plus 4 divided by, I need two numbers I can multiply and get a negative 2, but combine and get a positive 1. So that would be x plus 2 and x minus 1. I'm going to simplify this. And to find my 0, I'm going to take whatever is left in my simplified answer, which is x plus 4, set it up to be equal to 0. So the 0 for this problem would be a negative 4.